Okay, but let's just finish this unit by saying the one last thing I need to say about it. It's going to prepare us for the next unit, which is evaluation ring. To definition 8. So two valuations so say you have two valuations, but from the same field. So V maybe to some ordered group, and V prime from the same field, but maybe to another ordered group. Okay, I can't, in what will come later, I can't assume that they're the same. So I have to work with this generality at the beginning. Again, this is going to be easy in a week. So, but for now, that's what we have. So we are going, two valuations are equivalent, defining something. Length. If for every element in the field, there are, so the first one gives you a valuation which is larger than the 0 in that particular group, if and only if the second one does the same with its own 0. Okay, so if two evaluations are equivalent, if every element that is positive in the one or non-negative in the one is non-negative in the other. Okay. Like maybe, evaluation, you can take evaluation, and you can think of it as z, and you can multiply it by 2. It's just a stretch. So that's a way of getting another valuation, which is technically different. This is z and this is 2z, and it's not the same numbers, but up to that, it's the same thing. It's the same positive and negatives. Okay? Okay. We care about the pole order, but with the first thing we care about is whether it's a pole or not. And that is preserved here. If you are non-zero, and this is if you are larger than 0, then you are larger than 0. Maybe the numbers are different, but at least the question of whether or not it's a 0 or a pole, it's the same, you get the same answer. No, it's not good. So from this, it kind of follow immediately, because you can do like minus, do an inverse. This part of what is going to come is that they are also 0 together. So once you know that, it means that they are also, so V of A is 0 if and only if V prime of A is 0. And I'm not sure if that implies this, but that implies that. But don't worry about that. So because now there will come a claim which is will in particular implies that. It's a non-trivial claim actually. So it's the first non-trivial claim that we have, I think. But it's not hard, just like not obvious. So V and V prime are equivalent. I gave you an example of how to do it. Like you can take one valuation and you can kind of stretch it, like multiply by 2. Or more generally, you can, if it's not z, you can take this thing and compose it with some function that preserves the order, something like that. So what I'm saying here is that's the only examples that you can have. So two valuations are equivalent if and only if there exists an order preserving group isomorphism I'll draw a picture in a second, such that V prime is lambda composed. So what am I saying? Say you have two equivalent valuations. When I claim you kind of cheated, it's the same valuation really. What do I mean? So let me draw this picture, which would help. This is the field where the two valuations walk over. And then, one valuation, take it to, technically a subgroup of gamma, but, it's image, which we kind of identify with gamma in my mind. And then V prime takes it to V prime of F star. And that's okay, that's the general thing. And what happens is that I'm claiming the two valuations are equivalent, is equivalent to saying that there is a way, there is another function from the image of V to the image of V prime, or really you can think about it from that group to that group. It's an isomorphism. Okay, so these are the same groups. These are the same groups really, maybe Z and 2Z, but same group. And not only it's an isomorphism, it's also order preserving. Namely, two elements here, A is smaller than B here, according to V, if and only if lambda of A is smaller than lambda of A. So it really means that they are the same thing. Okay, that's what I mean. And the picture that mathematicians like to do is this. I want to say that, this function and that function are the same. No matter how you go from here to here, whether going through V prime or you do V and then compose afterwards with lambda, you get to the same function. So they call it commutative diagram. This is a you can commute. You can commute from here to here or from here to here and do the same way. And so is it clear? Like this is what I did really. So it's the one direction is obvious. If this holds, then clearly they are non-negative together, because lambda will not reverse a non-negative element to a negative one. Right. So the one direction is obvious, that if you have this lambda between V and V prime, then they must give you the same or really equivalent valuations. The other direction is more interesting. It's a one-liner. After what it has said, it's a one-liner, 2 lines, but it's a kind of like a one-liner that you need to see maybe. Okay. So let me just end with that. So first of all, I claim that, so I'm kind of assuming that V and V prime are equivalent, and I want to prove the existence of this lambda, which is not obvious how to do, right? Because you need to cook up an isomorphism between two groups you not know much about the images of those. So I don't know if you can guess how I'm going to do it, right? But so the first observation is what I said, and that's that this condition means that they're also zero together. Sorry. Right, I said not larger or equivalent zero, but that implies that, because you can look at the inverse. So this means that the kernel of both homomorphisms are equal, and then you're essentially done, because this means that this is equal as a set, right? Same set, just looks weird. And that's equivalent, according to the first isomorphism, to the image of the first valuation. See, it's a little bit abstract. And that's isomorphic with the same reason to that. And so that induces an isomorphism, which I'm not specifying, but you can figure it out. From here to here, that's your lambda, right? It takes a number, an element in gamma, finds an element whose valuation is that, and takes the coset, use the same one, and go back from the coset to the number. So it's a weird lambda, but it appears here implicitly. The only thing you need to check you need to check isomorphism, that's obvious. The only thing you need to check is order preserving, but that's also kind of obvious. Good, so that's for today. Next time we are going to talk about valuation rings, and yeah, it's trivial because you can do VA inverse. You can look at that. So this holds together also, right? But that's the minus, so trivial. Okay, see you next time.